Today we're going to do analysis of planetary gears, and we have to finish planetary gears today, and then we are going to go for instantaneous center, still dealing with the topic of velocity over here. Okay, so I need you all to go to the notes yesterday, and I will start by looking at this by analyzing, not solving yet, this question and see what it actually means in a certain part. Or what does it mean that this is a sun gear, this is a planet gear. Yesterday when I asked in class, I realized there's a good mix of students down here. Now, is the lighting too bright for you or this is okay? It's okay? Or you want it dark? No? Okay. So yesterday I realized that the class has a good mix of students from just straight mechanical and management. Those who are in mechanical and management, they're in their third year. Okay. So those of you who are in your second year, have you been taught planetary gears yet? Yes or no? You have been taught. So what can, like I asked further, what have you been taught in planetary gears? Can you tell me? So you know how to calculate the gear ratio and the function of it. Okay, so I'm going to give you a sort of open-ended question. In planetary gears, are all the gears always rotating? No, okay, so you're, okay, that's good. So I won't waste time on this video that I intend to show you. If you have that knowledge on planetary gears, I'm happy. Okay, right. So what we have over here is a elliptic-cyclic gear train, consists of what we call a sun gear. Okay. So sun gear is gear A, which is in mesh with the planetary gear B. Okay. So you come up with a name, sun, and then planetary gear. The gear has an inner hub C, right, which is fixed to B and is meshed with the ring gear. Okay, so over here we have a ring gear. Okay, if the connecting rod or the connecting link DE, okay, pin to B and C, okay, is rotating at omega DE at 18 radians per second about the point at E, determine the angular velocity of the planet and sun gear. Okay, so a lot of terms down here. Okay, so let's define the terms. When do they use the word sun and when do they use the word planet? Okay, like our solar system, by the way, my physics, I hate, you know, the planet, calculating those forces. I hate it with passion. Find absolutely useless, you know. But some of us might end up in as an astronaut. I'm not one of those. So you have over here, this is just a sketch, right? So at the center, this is always known as the sun. Okay, that's always, or I'll put on the center. So like our solar system, you have a sun. Okay, that's why we call it the sun gear. And the sun is always the center of attraction, like my daughter. And then around the sun, you have what we have over here. If I could draw it. Somehow this is not to scale, it's fine. I will shift it. Okay. And this ring that I'm going to draw, okay, this is our orbit. Our orbit in the context of planetary gears is what we call our ring gear. Okay. And on this ring gear, you have what we call a planet. Okay, so I'm going to, and this planet, and let me put in the same orientation. Okay. So this gear that is going around, okay, it has a center. This is known as our planet. Okay. So as you can see from here, you can see the resentments now, right? So we know, right? This is known as our ring gear. Okay. And the gear at the center not always has to be the biggest. Okay, the sun is the biggest in our solar system, right? So this is what we call our what? Sun gear. As long as at the center, we classify it as the sun gear, and the thing that's rotating around, that is our what? Planet. Are we clear? Okay, so this is the definition, okay, and we're going to solve this problem over here. Right. So what is given to us, okay, what is given to us is omega d is equal to 18 positive 18K radians per second. Okay. So we draw our transformation. Okay. So X, Y, and Z axis. Oh, K is not there. K is on the center. That is our K in Cartesian coordinate. Okay. I'll be honest with you now. I have not a clue how to calculate the gear ratio. Okay, I'll tell you now. My mind is buzzing. How do you, but we can calculate other stuff, but you tell me, Eugene, do you know how to calculate the gear ratio? I tell you no, okay? Anyway, I have to confess that, okay? You guys are like my mom and dad. I feel guilty not telling you. Right. Okay, let's get back to business. Now you don't know, now you know what I don't know. So what is given to us is the what? The ring gear is what? It's fixed. Okay, we know that the ring gear is is fixed over here. So we are going to call omega r, which is the angular velocity of the ring gear. And omega of the ring gear is equal to 0 radians per second. Now this is classified as our what? as our boundary condition given to us. Okay. So we are asked to find we are going to determine we are going to determine angular velocity of the sun and planet. So to identify the sun, okay, so we have to determine what is our omega AE, or I call it omega A. Okay, and omega A over here is our sun. And the next one we have to determine is our omega B, which is the planet. Okay, so there are two things that we have to determine. Okay, so as always, we have to identify our rigid body. Okay, so we are going to identify our rigid body. So I'm going to take this diagram, make it smaller, right? So our rigid body, right? We know that AE is a rigid body. So rigid body number one, right, is our AE, right? And then rigid body is our BCD. And we also have a rigid body. Okay, rigid body over here is our DE. Okay, so AE is our sun, BCD our planet, and DE they use a term, right? DE is our connecting rod or connecting link. Okay. So the first thing we are going to do, we are going to focus on, if I have enough space, I'm going to start on a new page. Okay, don't worry, I will get this whole diagram across. So we are going to focus on member DE first. Okay, we are going to focus on our member DE first. Okay, so we can write out VD is equal to VE plus by omega DE cross R D from point E. Now we were asked to find the velocity at this instance, okay? Or we are analyzing the gear at this instant. So I'm going to isolate the rest of the diagram, okay? And we are only going to focus on ED. Okay? Okay. So this is our point E. And over here, this is our point D. And we were given that omega DE is rotating at positive 18K, or I'm going to call this omega DE. Okay. So we also know that point E is what we call its spin. Okay. So when it's spin, right, VI or VEI and VEJ, wait, come on, really, are both equal to what? 0. Okay. So from here, based on the direction